Hey there, guys. So today we are going to learn about relations and functions. So what is a relation? So a relation is a set of ordered pairs or points in the form of x comma y. Now, these ordered pairs can represent either a relation or a very specific type of relation called a function. Another thing we're going to discuss is what we call domain of a function. And domains represent the input values. What do I put into the function? And these are also called our x coordinates. So domain, if I'm dealing with x, means that you're going to tell me how far to the left does the function go to how far right does the function go. So in this quick little example, we literally go all the way to the left at -5 and all the way to the right at +4. So those would be part of our domain. Now, range deals with all of the outputs of my function, which means these represent all of my y coordinates. So range deals with the y values, which means this is how low do you go. Do you go down low? All the way to how high up you go on the graph. So according to what we see, the lowest I go is -5, but the highest up I go is up here at +5. And we'll talk about how to write that here very shortly. There are 4 ways that we can represent both relations and functions. They are, we can write them in a table, ordered pairs or points, a mapping, or we can graph them. So there's your 4 representations right there. So the key thing here, guys, and the meat and the potatoes of our lesson is to tell whether you are a function or not. So the definition of a function is a relation that has, for every x coordinate, you are paired with only one y coordinate. So of anything you get out of today, I want you to know that to be a function, every x is partnered with only one y. So this first example is a list of ordered pairs. We can put those in the table. Our x's are the first coordinate, our y's are the second coordinates. And then we can also plot them on your graph. So -4 means left 4 and up 5, left 3, up 4, left 4, down 1, and right 5, down 4. We can also write this in a mapping diagram, as you can see there in the middle, where for every x, you are showing what y value it goes towards. So the domain goes from -4 to the far left to -3 to +5. Now notice I don't repeat -4 because I've already accounted for that value. Now as for your range deals with, so the lowest I go is -4 to -1 to +4 to +5 is our range. Now the last question is am I a function? To be a function, every x must go to only one y. And because -4 goes to 2 completely different y values, we can automatically claim, guys, that this guy is not a functional relationship. So because -4 goes to 2 different outputs, this guy would not be considered a functional relation. So in example 2, you guys can see the different formats of this mapping as a table and ordered pairs. And now we're going to figure out its domain. So as you can see, that your mapping diagram also gives you your domain and your range. Your inputs are your domain from least to greatest, and your range is how low to how high. Now, the question is this relation a function? And the answer is yes, it is, because for every x, there is only one y. So for example 3 and 4, we're going to look at the domain and the range. So remember, domain is how far left to how far right. And so as we look at our graph, how far to the left does this really go? Well, the arrow is pointing, which means that it continues on to the left, which means that we're going to approach -infinity on the left side. Now, same thing applies on the right side. You see that there is also another arrowhead, which means that I continue to the right on and on and on and on, infinitely to the right. Now, let's talk about range. How low did you go to how high do I go? When looking at the graph, guys, there is no lowest point I can be because my V just keeps going down and down and down and down infinitely. So if I'm going down infinitely, I'm going in the negative direction infinitely, comma. Now we're going to say how high up do we go? So what is the highest peak of that function that we see? And we see that we come all the way up here to 7. Now, I'm going to use this bracket to denote that I can be at 7. It's not an open dot. It's actually on the function. Now, this guy is, in fact, a function because for every x, we have one y value. So this guy is functional. For every x, we have one y. So in number 4, guys, we're looking at how far to the left to how far to the right we go. And notice that you're on a circle, so you do not go past a certain amount. So on the very, very far left, it looks like we do not go past -5. And -5 is actually on our circle, so we're going to give it a bracket, comma, how far to the right do we go? Well, it looks like we go to +5, so we're going to bracket that since it's on our function itself. Now it's time to talk about range. So how low did we go? In particular, it looks like we went down 5, and that's actually on our circle, so bracket, comma, how far up did we go? Well, we went up until we reached the tippy top, which is actually up at 5. So we're going to close that bracket since that is literally the top of our function. And the question is this a function or not? And the easy way to explain this is if I were to lay my pencil down straight up and down, how many times do I touch the function? So for every one x value, how many times do I touch my circle? Well, I should only touch it once if I am a function. But anywhere along the circle, as I choose an x value, it looks like I actually touch the function more than once. So this guy means no, this is not. So at every x, we touch the circle in 2 separate places, which is not functional. Time to play.